Welcome to Monochemistry. Today we're going to look at a concept called average atomic mass. An average atomic mass is a weighted average of all the isotopes of a particular element, and it's used to calculate the mass that you find on the periodic table. So for instance, the mass of carbon on your periodic table is 12.01. But how did that mass come to be? In order to understand that, you have to understand what a weighted average is, and also what an isotope is. Let's start with the term isotope. Isotopes are atoms that have the same number of protons, but different numbers of neutrons. Isotopes, therefore, have different mass numbers. A weighted average is almost exactly the same as a regular average, only in a regular average, every number you use counts as the same amount, counts as one unit. In a weighted average, not every number you use counts as a single unit. Some have a higher number of unit or a higher percentage, and others have a lesser percentage. Let me use this analogy here. See this group of marbles. If I was trying to calculate the average mass of these marbles, just for your information, there are 4 large marbles, and there are 20 small marbles. Would it be fair to just add them up and divide by 24? And the answer, of course, is no. It would be much better to get the mass of these smaller marbles and multiply them by their abundance, which is 20, and then take the mass of these larger marbles and multiply them by their abundance, which is 4, to figure out what the average is. Because there are so many more of these small marbles, they have a higher importance in the average than these larger marbles, which make up a smaller group, do. Now, how does this apply to chemistry? Well, in chemistry, we have different numbers of isotopes. Let's take a look, for example, at carbon. Here we have a picture of the isotopes of carbon. I'm just going to blow this up a little bit so you can see it better. There are 3 isotopes of carbon. Carbon number 12, which makes up 98.9%, or 98.89% technically, carbon 13, which makes up approximately 1.1%, and carbon 14, which makes up less than 0.0001%. So not very many of them around. So would it be fair then to add up each of these and divide by 3 to get the average? So 12 plus 13 plus 14 divided by 3. That's how we calculate an average, right? Would that be fair in terms of the average atomic mass of carbon? And the answer, of course, is no. So what I would do in this particular instance is I would use this equation here. This equation, and here's what this is. The average atomic mass, AAM, is equal to the percent abundance times the mass of a particular isotope added to the percent abundance and the mass of the other isotope. Now, if there was a third isotope, I would simply go plus the percent abundance of the third, which would be C. If there were more than 3, then I would continue going D, E, etc. But the general idea is the same. Now what I'm going to do is I'm going to show you how to calculate the average atomic mass for carbon. Okay. So in this particular instance, what I'm going to do is I'm going to plug the numbers into the equation. So the AAM, remember, stands for the average atomic mass. Little a, as you can see in the table here, stands for the percent abundance. Now notice here in my equation I'm dividing it by 100. You always have to do that. Okay, so you have to take this number and you have to divide it by 100. Same here. Okay, so as I go along, I have 0.98892 times 12. So this number, percentage-wise, times this. And then this number, percentage-wise, times this. I end up with 11.87 from this number, and I end up with 0.1440 from this number. Now I'm simply going to add them together to get my final mass. What is my final mass? Bring your answer to class. Now, really quickly, how you solve these problems. Step 1 is you create a table. You should write this down. These are the steps to solve these problems, average atomic mass problems. Step 1, you create a table. Step 2, you create an equation. Now, in this particular instance, there are 2 isotopes. If there were 3 isotopes, then I would continue my equation, and it would look something like this, plus little c over 100 times c. And if there was a fourth one, then I'd have a d, little d over 100 times d, and so on and so forth. You likely won't have very many more than 3 or 4 in any one given question, sometimes just 2, like in this question. Okay, then remember you divide your percent abundance by 100. You put those numbers here, and you multiply through there by the mass, which in this case is A and B, respectively. Okay, and then of course you add those numbers together. If there were 3 numbers, you'd add that other number together and that number, but in this case there's only 2. Okay, that in a nutshell is how to, first of all, what an average atomic mass is, and how to solve a problem of average atomic mass. Some questions are harder. Sometimes you'll have to solve for different parts of this equation. That's fine. You can rearrange the equation and solve because you're good at algebra. Also, it's important to note that every single number that you see in terms of mass numbers on the periodic table are, in fact, average atomic masses of those elements. Bring your questions to class.